In Chapter 8, we're going to start working with chemical reactions. We'll use those formulas that we learned how to write in Chapter 7, and we will be writing chemical equations. In this chapter, we'll learn how to balance, and then in later sections, we'll be doing other things with those reactions. So, first of all, what is a chemical reaction? So, here you're going to have some substance or substances changing into different substances. So you start with one or more things and you end up making something new, either one or more things in the end. The reactants are the substances that go into the reaction. And you can think of these like your ingredients when you're making a recipe. So, what are you starting out with that you will then change into something new? Products are what are produced or what are made in your chemical reaction. So if your ingredients were maybe sugar, flour, water, you put all those things together and you might make a cake. So a cake would be your product. One thing that we have to keep in mind, whatever we put in, the mass of that all added together should equal the mass of what comes out. Now, if we were making something like cookies, so if we put all the ingredients of the cookies together and we were to find the mass of that, make the cookies, and then find the mass of the cookies afterwards, those should be equal. But sometimes maybe there are gases produced that escape, and so the mass might be a little off. But in a chemical reaction where we're able to capture all of the ingredients, all of the substances produced, then the mass before and the mass afterwards should be equal. When we're looking at a chemical equation, it is going to give us symbols and it's going to give us formulas that tell us what type of substances are involved. It's going to tell us what the reactants are, what the products are, how many of each we need. Sometimes it's going to tell us are these things solids, liquids, gases. It might tell us how much we need to heat these up to make this reaction happen. It can tell us many different things. Some things that indicate that a chemical reaction is happening are the production of light or heat. If you pour, let's say, two clear liquids together and you still have a clear liquid there, how do you know if something's happened? Well, you can feel the maybe beaker that you have those in. Did it get hot? Did it cool off? That would indicate that you had a chemical reaction take place. Are gases produced? And one way to tell if gases are produced, do you have bubbles? So if something bubbles, you're having gases made. A formation of a precipitate. So a precipitate is, if you look here, you've poured two liquids together and then you get some cloudy solid that separates out. If you've ever mixed orange juice and milk together and then you get this weird chunky substance, that would be a precipitate. If you've never done that, there's a good at home experiment to try. Another sign of a chemical reaction would be a color change. So if something changes colors, you've had a chemical reaction take place. Some things that you have to have in your chemical equation, you have to have known facts. You have to have accurate equations written, formulas for what is being used, what's being produced, and the law of conservation of mass must be satisfied, meaning you have to have the same mass going in as coming out. Coefficients are going to be something new that we'll use in this chapter. So those are going to be the whole numbers that will be placed before the formulas in a chemical equation. Now, these are whole numbers and they're typically small numbers. So, by small number, typically less than 20. We may have 25, I think, on one of our problems in the homework. But You're not going to have like 100 or 200 typically. So these are going to be small numbers that are placed in front of the formula. So if we look at this here, this is saying I have 2 water molecules produced. So then if I ask, okay, well, how many hydrogens do I have there? This 2 is going to multiply all the subscripts in that formula, in the substance that it's right before. So this would give me 2 hydrogens, I'm sorry, 4 hydrogens and 2 oxygens. Over on this side, we've got a 2 in front of this hydrogen, and if this box goes away, there it goes. So on the reactant side, you have 4 hydrogens, and then there is nothing in front of that O2, which is just like everything else in chemistry means a 1. So there we have 2 oxygen atoms in this set right here. A word equation is going to be a chemical equation that you just use words instead of writing the formulas out. So I could say water produces hydrogen and oxygen, but I'm not necessarily writing the formulas. Formula equation, you are going to have to write the formulas. You're going to have to write them correctly. If they're not written correctly, then that will cause you problems down the road. Some symbols that you may see, and if they are in parentheses like this is telling you what state the substance is. So let's say that I see H2O written, and then there is a little G in parentheses after that. That just means the water is a gas. Maybe I have H2O, and then I have an S after it. That means my water is a solid or ice. Now this last one, aqueous, sometimes people aren't familiar with that, but aqueous just means that it is in a water solution. So maybe I have HCl, and then it says aqueous. So that just means I've got salt dissolved in water. These are some more symbols that you might see written in a chemical reaction. So the arrow, that means yields or produces, and that's going to separate your reactants from your products. So on this side of your arrow over here would be your reactants, and then after the arrow would be your products. Now, if you see something that looks like a double arrow or 2 arrows on top of each other, that means it's a reverse reaction. So it can actually go back and forth. You make something, and whatever is made can actually break apart and become the reactants again, and that can go back and forth. The S in parentheses, in the last slide we looked at that meaning a solid, which a precipitate is a solid that's produced. So it basically means that we have a solid. Gaseous is G. Then if we have the yields or the produces arrow with a triangle over that, that means we have to heat the substances up to get them to react. If we have to heat them up to a specific temperature, they will put that temperature over the arrow. Instead of the triangle, we have 50 degrees here, so maybe we have to heat it to 50 degrees to get it to react. So some things about a chemical equation that are important. They're going to show us what substances are needed for a reaction, what are produced. It will show us the ratio of the substances that are needed to the substances that are produced. It'll show us the masses of those, and we'll use the coefficient to determine some of these things, and if there is a reverse reaction. Balancing equations is going to be very important. You might have done this in junior high with some very simple ones. We're going to do some more complex ones, but we're going to be using those coefficients to change the number of the substances that are involved. And you can only change the coefficients. You can't change subscripts. You can't add other substances. You can only change the coefficient. So if we look here, we've got 2 hydrogen atoms bonded, making a hydrogen molecule. So that formula would be H2. And the same thing with the chlorine. These are bonded together, so this would be Cl2. On this side, we've got HCl. Well, here we have 2 hydrogen atoms, and we only have 1 over there. So this is not a balanced equation. So we're going to look at how do we get balanced equations. So the first thing you want to do is identify all the reactants and products that are in the equation. From there, you want to write the formulas correctly for the substances that are involved. Now, when we're looking at water, water is H2O, and then it said hydrogen and oxygen. Here I have it written as H2 and O2. We have to remember those diatomic molecules. And so if you don't remember those, write them down. It's going to be hydrogen, nitrogen, oxygen, and all of group 17. So if you have in your word equation, let's say something produces nitrogen, you would not just write produces nitrogen, you would have to write N2. And this is only when those substances are by themselves. If it says it's nitric acid or if it is carbon monoxide, if it's in a different formula, then you follow the crisscross rules and all of the naming rules that we looked at in chapter 7. But if it is just one of these substances by themselves, so for example, chlorine is in group 17. If you have chlorine produced, you would have to write it as Cl2. So make sure you know these diatomic molecules. We will be balancing the formula according to the law of conservation of mass, which means we have to have the same mass of all the substance on one side as the other, or the same amount of substances on each side. To do this, you're going to balance one substance at a time. And by balancing one substance at a time, it will change some of the others, and then you're going to kind of have to work back and forth like a puzzle. I would also look at some of those substances like H and O that might be separate by themselves. So here, if we look at this, what I always do is I use my produces arrow, my yields, as kind of my middle ground, because that is where you have to keep the balance. So on the reactant side and the product side, you have to have the same amount of each substance. So what we're going to do is we're going to make a list of all the elements involved. And I always make it right under that arrow. So we have hydrogen involved and we have oxygen. And now at this point, I determine how many of each do I have so I know am I balanced or not. So on the reactant side, this is the reactant side and the product side. For hydrogen, I have 2. And over here on the product side, hydrogen, I have 2. So those are fine. Then my oxygen, I have 1 on the reactant side and 2 on the product side. So those are not balanced. So I actually need to get that to be a 2. So to do that, I have to change my coefficient out front. So I'm going to make that a 2. So now I have 2 oxygens, but that changed my number of hydrogens. So I'm going to now have 4 hydrogens over here. So now my hydrogens are not balanced, but that's going to be a little bit easier to fix. So if I just put a 2 in front of this hydrogen, now that gives me 4, and I've got 4 and 4 hydrogens and 2 and 2 oxygens. So my balanced equation is going to have 2 waters, 2 hydrogens, and this is understood 1 oxygen. Now I want to count, and we just did that to make sure that everything's balanced. And I'm going to simplify if I can. So on that last one, my coefficients were 2, 2, and 1. Let's say they were 4, 4, and 2. I could reduce those down and simplify. Let's look at this one. We've got a few more atoms involved here, a few more elements. So we've got nitrogen, and we're going to make our list. We're going to use a different color. Let's see. So nitrogen, and we've got hydrogen, and we've got oxygen. So how many do we have on each side? Nitrogen. I have 1, 2 nitrogens here. And on this side, I've got 2 nitrogens. Over here, I've got 4 hydrogens. And over here, I have 2 hydrogens. And then oxygens, 3 and 2. So make sure you count all of the atoms involved. Now, at this point, I can pick any of these substances to try to balance. My nitrogens are fine. So let's just go ahead and go down the list. Let's try to fix our hydrogens. So if I fix my hydrogens, I need to put a 2 here. So that gives me 4 hydrogens, but that changed my oxygens. So now I've got 2 plus this 1, so that's 3 oxygens. So that actually fixed my oxygens as well. So I've got 1, 1, and 2 for my coefficients, and I'm balanced. Let's look at another one. So here's my arrow. So I'm going to make my list. I've got La, I've got O, and I've got H. So I have 2 LAs on this side and 1 on this side. Oxygens, I've got 3, 4, and over here I've got 3. And hydrogens, I've got 2 and 3. So we'll just go straight down the list and try to fix things. So La, we'll put a 2 out here and see what that does. So that gives me now 2 LAs, but now that gives me 6 oxygens and 6 hydrogens. So let's see what we can do to try to fix our oxygens. So we've got 3 there. Let's put a 3 here. So that gives me 3 plus 3 or 6. And a lot of these things you're just going to have to guess and try different things and go back and forth. So we fixed our oxygens, but now our hydrogens we have changed. So now that's a 6. And so we are balanced. So 1, 3, 2 are my coefficients. Here we have K, Cl, and O. Our O's may be the easiest because oxygen's kind of by itself, but we'll see. So let's make our list. 1 and 1, Cl 1 and 1, and O 3 and 2. Now, one thing that is often helpful, if I see I've got a 3 here and a 2 here, if I kind of swap those, so this side has a 3, so let's put a 2 out front, and this side has a 3, now I've got 6 of each. So 6 oxygens there, 6 oxygens there. But what did that do to my KCl on this side? So my K is now a 2, my Cl is now 2, and so then that's easy to fix. 2 of each of those now. Here we have nitrogen, oxygen, and hydrogen. So we've got 2 nitrogens and 1. We've got 5, 6 oxygens and 3. And hydrogen, we've got 2 and 1. So we'll just pick out what might be the easiest. We'll start with the nitrogen. So there's 2 on this side, so we'll put a 2 here. So that's going to change my hydrogens to 2, my nitrogens to 2, and my oxygens are now 6. And so now everything matches up. So we're already done with that one. All right, good luck.